So, good morning, everyone. I'm Dave Whyte, the operations lead at AutoTrader. I'd like to thank Ethan and the organisers for putting together not one, but two great new conferences, especially as they're both hosted here in sunny Manchester. I'm honoured to have been asked to share AutoTrader's migration to the public cloud. First off, brief apology. I've got a really sore throat, which isn't good. And when I was practicing this presentation, there's a good feature in PowerPoint called Coach, and it told me that my delivery is very monotone, which isn't a good start. So that's probably because sore throat, but B, it's also through the amount of trying to cram into a 40-minute presentation. So if you feel a bit sleepy, please pinch yourself so you stay awake. That'd be gratefully appreciated. So fasten your seatbelts, sit back and relax as I take you on a multi-year adventure. I hope our story informs and inspires you in your cloud adventures. So let me take you back to the origins of AutoTrader. Originally, we were a weekly print publication, a cornerstone for anyone in the market for buying or selling a car. In June 2013, we made a significant pivot, publishing a final magazine after 36 years. This marked our first major transition from print to digital, a move that reshaped our business model and stands as an intriguing story on its own. This change allowed us to dedicate ourselves entirely to enhancing our online platform. Today, AutoTrader is the UK's largest digital automotive platform. We play a pivotal role in connecting car buyers and sellers nationwide. Behind these impressive numbers is a dedicated team of 1,300 employees, including 400 developers, and a lean team of 5 excellent delivery platform engineers. Before we hit the open road, let me share the agenda of the talk. It's broken into 3 parts. First is life in the slow lane. Keeping it simple, this is pre-migration. When I say slow, for clarity, I mean this is referring to the speed of our org's agility at that time. Secondly, shifting gears to the public cloud. This is our migration window. And lastly, cruising in the fast lane. This is post-migration. So let's make a start with life in the slow lane. On the slide, you'll see our 2 data centers. These were the backbone of our infrastructure for many years. These were fully managed by our in-house operations and infrastructure team. It was a complex setup that required lots of love and attention to operate efficiently. I'm sure everyone feels that with their data centers. Our default setup was to run active-passive, all traffic directed towards one data center. Releasing application was a very complex process with multiple pipelines and switching application traffic between data centers. If a release went live and negatively impacted our customers, rolling it back would take approximately 30 minutes plus, so lifetime with impacting customers. Before we embarked on our public cloud journey, we had an adventure with the private cloud. With the private cloud, developers were able, for the first time, to deploy directly to our live environments without requiring involvement from the release management team or change management. This was a big change. There was lots of concerns that this would cause chaos, but it didn't. We sent weekly reports to senior leadership that highlighted any failed releases to ensure accountability. This approach kept teams vigilant. No one wanted their app to be featured in this report. Bit of a carrot and stick approach. Managing the private cloud for us had its challenges. We opted for an open source solution, which led to numerous operational headaches, limited support, and dependency challenges. While the private cloud provided viable lessons, it ultimately wasn't the right solution for us. This picture is a blast from the past. Apologies, it's a bit blurry. This was our initial attempt to diagram how everything was interconnected, which apps connected to which databases and so on. We used this for troubleshooting incidents at the time. I laugh now. However, it often led to more confusion than clarity. The diagram was outdated almost as soon as it was created, turning troubleshooting into more of a guessing game based on assumptions rather than solid facts. And no one wants to be in that position. So why the public cloud? Moving to public cloud isn't a decision to be taken lightly. After weighing up all the factors, you might even decide it's not the right move. I'm going to pause to see if any vendors will give me the evils or anything about that statement. But seriously, it was a major decision for us. 2 key events ultimately steered us towards the public cloud. First, we welcomed a new senior SRE into the team. He brought a wealth of cloud experience with him. Secondly, we had a complex challenge with end-to-end encryption. Initially, we believed we could resolve this within 6 weeks in our private cloud. However, with little progress, 3 months later, we began exploring other options. We decided to conduct a test in the public cloud and had a working solution in 2 days. I'm not making this up. This experience didn't just highlight the speed, but also the agility the public cloud could offer us. After more experimentation, it became clear that the public cloud was where we needed to be, not just because we wanted to be one of the cool kids, but because it genuinely met our specific needs. This leads into the next section, the migration. At the onset of the migration, we agreed some clear lines in the sand, right from the top of business down to the bottom. First, we aimed to fully migrate and decommission our data centers. We did not want to be supporting a hybrid cloud setup. Second, our approach wasn't just to lift and shift. We aimed to adopt new ways of supporting services that fully embrace cloud-native capabilities. Thirdly, we committed to building our new platform as a product, designed for developers. The platform should have a focus towards ease of use, reliability, and self-service, enabling developers to work efficiently without concerns for the underlying infrastructure or needing direct access to the public cloud. A crucial consideration of any cloud migration is the impact on your people. Before the migration, our ops and infrastructure teams had dedicated years to managing the data centers. Running them was second nature to us. We lived and breathed data centers. We knew that announcing plans to migrate to the cloud and close data centers would raise concerns amongst our teams. Would their roles change? What new skills were required? Will they lose their jobs? To address this, we initially sought advice from some cloud vendors and spoke to their customers who had faced similar challenges. One company, I'm smiling at this, but read this out. One company advised us that they created a new cloud team for the migration, and then at the end, they got rid of the old team. That was their approach. This was not the approach we wanted to take. Instead, we opted for an open, honest discussion with the team. We assured them that there was no plans for layoffs and presented the transition as opportunity for cross-skilling and acquiring valuable cloud expertise. True to our culture, the team tackled the migration head-on. In truth, being open, whilst we intended to keep all our staff, as the migration approached completion, we needed to make a few network engineers redundant. This wasn't a good news on a sad day. This was due to reduced demand for on-premise infrastructure management. Reflecting overall on the journey, I believe we struck the right balance. Most engineers seized the new opportunities, and our team has successfully adopted to fully supporting our services in the public cloud. Let's take a high look at our high-level view of the architecture. Our delivery platform is structured using a microservices approach. It runs on Google Cloud Platform and leverages Google Kubernetes Engine. To manage the complex traffic between these microservices, we use Istio's service mesh. Think of Istio as a smart traffic controller that manages communication, security, and monitoring across all services without needing to change the actual microservices. All our traffic is routed through Cloudflare, which provides a robust DDoS protection. This setup functions essentially one virtual data center. So here, asking, what about high availability and resilience? To achieve this, we have the same setup across 3 zones, essentially 3 separate data centers. All 3 zones are operational and share load equally. In our standard production environment, each service operates at least one pod in every zone. enhancing both resilience and redundancy. It's important to highlight at this point that we don't implement any auto-scaling at AutoTrader. Our traffic patterns are very predictable. We don't have Black Friday or stuff like that, thankfully. We allocate sufficient resources to each service to manage its peak load plus a safety margin. This arrangement guarantees that losing a single zone won't affect the service. If a major disaster affects the main region, we have critical services set up in an alternate region. This configuration supports our homepage and fundamental search functionality, ensuring we maintain an online presence in disaster. However, if this occurred, I think the last thing people want to be doing is searching for a car. We also have connectivity from GCP to Azure and AWS. This is primarily for our data and enterprise services, although the data stuff is actually being migrated into GCP. During the migration, our old data center maintains active, maintaining connections from GCP, AWS, and Azure. While the setup might work well for some, for us, it was an absolute nightmare. We faced multiple connectivity issues during this period, especially as our databases were some of the last components to be migrated from the data center. Services talking from the cloud to our data center, latency hell, vendors blaming vendors, not a good period in our history. So let's get into the actual migration. I thought it would be insightful to break down our approach to migrating an application from a data center to the cloud. First, we create a working group channel in Slack. We use Slack for internal communications and invite all the stakeholders for the app, including ops, into one channel. Focusing on the app and the data center, we document the current resources that are being used for the application. In this example apps, it's running on 12 servers, 6 in each data center. So 6 is the servers we need to be focusing on. Each server has 2 CPUs and 4 gigabytes of RAM. These are all completely made up figures, might not match, but I'm trying to set the example. Next, we estimate the cloud requirements. In this case, we predict it will need 9 pods. Each pod requires 60 millicores, 80 millicores, of CPU, and 100 megabytes of RAM. We then deploy the app onto the cloud platform. At this stage, it's not serving any real traffic. We then review the data, checking for any obvious issues. Once we're satisfied there's no issues, we agree on the best time to switch the app traffic from a data center to the cloud. We then monitor the data closely. If there's no immediate issues, we'll leave overnight and review in the morning. If there are any issues overnight, our ops team are in the loop because they're part of this Slack channel, and they can easily switch data back to the data center, minimizing customer impact. If all is well, the following day, the initial part of migration marked as completed. After a few days, we create a task to decommission the old infrastructure. Some companies I've seen keep the infrastructure hanging around to the end of the migration. I don't think that's a great idea. We wanted to kill off old stuff as we go along. It makes sense to us. So, the first step is complete. But remember, I said we weren't just going to do a lift and shift. As the services run in the cloud, we now have a load of service metrics and other data. I'm sure many of you have had those moments when you're investigating an issue, you spot an error, then realize that isn't the actual error you were looking for, and that one's been there for years. Rinse and repeat, you do the same sort of thing. It's demoralizing and often makes you want to abandon investigation altogether. We wanted to clean up the logs, fix long-standing errors, and ensure the correct response codes were being served, which is crucial for Istio. Doing this now saves countless hours of troubleshooting later. While analysing the data, we frequently spotted traffic patterns that warranted further investigation. Patterns we couldn't see on the old platform. In one case, we spotted a customer placing a significant load on our main API during our peak hours. We contacted them and got them to agree to shift their heavy usage to the early hours of the morning, bringing down the load on this important application. After a week of closely analysing the data and fine-tuning, we typically found that the CPU memory usage had changed, decreased dramatically. So our final task was to adjust the resources accordingly ensuring cost efficiency in the long run. In May 2023, after a dedicated 4.5 years migration journey, we powered down our data centers for the last time. I get a whoop whoop. The sense of achievement was friggin' immense, absolutely awesome. Which then brought us into a new era, which was cruising in the fast lane. Let's dive into some of the key benefits we've experienced since moving to the cloud. Firstly, our monitoring and observability have transformed how we operate, giving us access to some real-time data, enabling us to investigate issues in seconds. Our incident response times are now much faster. With reduced mean time to detect, we can catch issues as they happen, allowing engineers to respond immediately and significantly lowering our mean time to resolve. Ownership and agility have also had a substantial boost. Our internal tools have built-in accountability, making it easy to pinpoint who needs to take action when issues arise. I'll showcase this in a few slides. Regarding agility, we can now take a product idea and deploy a service as quick as you can deploy the code, without raising tickets or configuring servers. If a service is no longer needed, we can quickly remove it and the associated pipelines with the push of a button. Our ops and delivery platform teams no longer use tickets or ticket systems for service requests. Almost everything developer needs is available through self-serve. If questions do arise, all we have to do is post a simple message on our Slack channel and we'll respond within minutes. A major benefit is the reduction in maintenance. With Google managing the underlying infrastructure, we no longer need to manually patch thousands upon thousands of servers and network devices. Database maintenance is mostly automated, and downtime is minimal, usually less than a minute. Google cluster upgrades initially caused us some unpredictable impacts. We've since made some adjustments, so now there's no service impacting, or not service impacting. We used to do a ton of manual maintenance and stuff out of hours. Lots of downtime, lots of upset engineers. Now, there is limited manual maintenance, and all maintenance is done in working hours. Nothing is done out of hours. Additionally, we've implemented a comprehensive service catalog. I've been AutoTrader for 20 years. We've never been able to implement a service catalog before. They're hard to do. We have now got an awesome one, and I'll showcase this shortly. Finally, we significantly strengthened our security. We now scan code for vulnerabilities during deployments and conduct regular security audits. As mentioned before, we also use Cloudflare and benefit from its DDoS protection and bot protection. In the past, us getting hit by DDoS was, oh my God, alarm bells going off, nightmare scenario. Now, we see a very small blip in traffic. We get an email telling us, by the way, you've been hit by a DDoS, and it's all managed. Obviously, we still take it seriously. We still investigate to see if we can improve anything with the relevant firewall rules, but a lot better position to be in. Together, these monitoring, maintenance, agility, and security improvements have been game changers in our cloud journey. Let's take a look at this graph, illustrating our release velocity from 2012 to today. I think I sort of hear some groans by some of the talks yesterday about it's not all about release numbers and stuff like that, and it isn't. This reveals the story of our evolution, marked by key milestones that have significantly changed how we deliver software today. In the early years, we were performing manual releases, logging onto servers one at a time and deploying code individually. This was time-consuming and prone to error. We then implemented auto-deploy. This advancement allowed us to push releases to multiple servers at once, simultaneously, greatly improving our efficiency and increasing our release frequency. We then built a private cloud. This shift provided developers with more flexibility, enabled some self-serve capabilities. Developers can now deploy releases straight to live, accelerating our deployment cycles. And this last one was sort of like a stairway to heaven or the cloud. This period marks our move to public cloud, which boosted our ability to deploy releases quickly and reliably. While the increase in release velocity is impressive, our main goal is delivering value efficiently and securely, not just ramping up these release counts. We don't have any internal targets around release numbers. However, we adhere to policies of deploying a new release for every service at least every 60 days. So you've got multiple services, you have to make a deployment to your service every 60 days, otherwise you get in trouble. We do this to ensure that all services are up to date with platform enhancements and you tackle the latest CVEs. If you don't do that and don't deploy every 6 months, then you've got a million CVEs you've got to tackle, and it's not a good position to be in. Also, many of our services use continuous deployment, where you change a single line of code, and that gets deployed all the way to production. And yes, again, this graph makes a great conference slide, but truly reflects our commitment to agility, security, and continuous improvements, not just more releases. With such a high velocity of releases, it's crucial to have a clear visibility in what's being released and when. This slide shows a screenshot of our internally built service called Lighthouse. It's our release dashboard. This is a view of our production releases. Focus on the first entry, you can see the exact time the app was released to production and how long the deployment took. On the right-hand side, you can view any current releases that are in progress. If you're investigating an issue, this dashboard is a great resource for checking related releases that might be the cause of the issue. During our migration, we tracked release data, from both cloud-based services and those apps still running in our data centers. This allowed us to send out automatic weekly updates comparing cloud versus data center, providing a clear visual indicator of the overall progress of our migration. Here's our platform dashboard. It's our internally built service catalog. The dashboard provides a comprehensive view of all the microservices running on the platform. You can see there's currently 723. That's in our production environment. Let's focus on a service called A/B Test Allocator. If I click into it, I'm taken to a dedicated section that provides all the information I need to know about that service. Along the top, you'll see tabs for workload management, schedule tasks, suggestions, network policy, and admin. Each section provides valuable self-serve tools and information that help with supporting that service. Fortunately, really restricted on time, so I can't dig into that in more detail. The next section covers service owners, service maintainers, and domains. This part is pretty straightforward. A service owner is the primary contact for that service. Service maintainers are individuals or teams tasked with maintaining that service. Both the owner and maintainers receive alerts if any issues arise with that service to complete ownership. The domain indicates which business area the service sits. Think of domains as tribes. We shall squad tribes, and we've done a restructure AutoTrader, so now it's domains and communities and all this other stuff. Again, probably a talk in itself. All this info is taken from the service's source code, so it's a simple source of truth. Here you can see the related value YAML file. The names of the owner, maintainers, are the same as the ones on the dashboard because that's where it's dragged from. You also notice a list of contributors. These are individuals who have commit access to the service's repo, but they don't receive any alerts if there is a problem with that service. So sort of like reducing alert fatigue, etc. Back to a dashboard. This section of the service links. Essentially a list of useful links or bookmarks for the service, including active alerts, application logs, Git source code, pipelines, tracing, and much more. Previously, new developers joining the company would often submit a service request asking for these links for their service, which was a nightmare. With everything readily accessible in one place, such requests have now been eliminated. And again, we don't have any more service requests in our teams. So how do you add a new service or data product? Simply enter the necessary details in the initialized project section, and you'll be up and running within minutes. When deployed for the first time, all the monitoring, observability will automatically be hooked up to the service without you really need to do anything yourself. Another useful feature is dependencies. Imagine your security team alerting you to a serious vulnerability in Node 10, for example. Identifying and updating all affected servers can be tedious and time-consuming. In the platform dashboard, we can easily see a list of all the apps running Node 10. down to the specific version of Node 10. With this info, I can easily reach out to all maintainers, advising them they take some action. Normally, again, we create a working group, so working group in Slack, invite all the people in. I can easily keep track of the progress by just refreshing this page. So in theory, if I've got to move off it, I see the apps dwindling down. That's our platform dashboard. This is version 1 of the dashboard. We're already working on version 2, which will include a ton of new features and innovations, which should give me plenty of material from my next talk. Okay, this is very busy dashboard. This is our service mesh dashboard. Again, a lot happened here, so I'm going to break it down. First, let's look at the overall throughput of our production cluster. This section helps us quickly spot any serious issues, such as DDoS attack or a significant system issue that results in a drop of traffic. And this is instant. We can see it instantly, real-time data. Next section shows errors by service. This displays any services, so any of those 723 services, throwing 500 errors. While there's always some low-level noise, as you can see, it's a good place to quickly spot something going wrong in real time. My team have got this in a second screen and normally glance at this graph frequently throughout the day. Now, those with sharp eyes may have noticed that there's 2 spikes in different sections that warrant further investigation. This shows some services are experiencing gateway errors, timeouts, so let's see if we can work out what the cause is. Let's zoom into one of those graphs and highlight one of the data points. When you do this, it reveals a list of services in error along with the immediate path. I've highlighted one of these, which shows ingress engine X going to portal gateway. This top-level dashboard provides a high-level overview, but I can dig deeper by accessing something called the service health dashboard. So I'll click through into that. On the top left, you'll see the namespace and the workload. Now, both are set to portal gateway. That's not a duplication. You can have multiple workloads in the namespace. This dashboard contains a wealth of data for that service itself. With a microservices architecture, where many services are connected, identifying the root cause of an issue can be challenging. So how can we quickly pinpoint which service is causing this problem? On the left-hand side, you'll see the services that call portal gateway. And there's only one, ingress engine X, which makes sense as portal is a gateway service. You'd actually expect a lot of service to talk to it. On the right-hand side, you can see the service that portal gateway talks to, multiple services. You can see the spikes on both the left and the right-hand side. This quickly indicates that the issue is not with portal gateway, but with the service further down the stack. But which one? The gateway calls many services, as said. I could go through them all one by one, but I'd be here forever. So there's another link back on the board, which takes us through to tracing. Focused on the data on the bottom left-hand side of the screen, I can immediately see or spot a load of 502 errors. So these are the errors I'm looking at. And at a glance, I can see the path associated with each error. This can be really valuable when you're investigating an issue. On the far left, you can see trace IDs. So we use Jaeger tracing at AutoTrader. We retain traces for every transaction across our entire platform, from Cloudflare right to the end of the stack. We store these for 3 days. We don't see the point keeping them for longer, and it's a lot of data. If you don't use tracing, I really recommend, if there's one thing to take away from this talk, look into tracing. It's pretty awesome and really helps investigating issues. Let me click into one of these traces. When we examine the trace, it reveals a wealth of information. We start from the top and work our way down to understand the flow. At the top of the trace, you can see portal gateway service. This then talks through to portal service, then through to vehicle data service. Finally, you can see URL automotive MXM. I recognize this as an external endpoint for Experian. Yeah, love-hate relationship with Experian. No one works with Experian here, do they? It looks like they've had a brief issue, resulting in our service timing out after 15 seconds. Now, this was just a blip, so it's not really worth raising with Experian at this point because it ain't ever going to get looked at. Obviously, if we see more occurrences of this, then we should raise it with their support. Now we've got the data to help them investigate the issue. But this just highlights this type of investigation. My team carries this out multiple times a day. Typically, no action is taken, like for this. Though sometimes we might uncover a real serious issue that needs investigation that other monitoring hasn't picked up on. Hopefully, this demonstrates our improved real-time visibility and how straightforward it is to investigate and identify the root cause of issues. Now, you might be sat there thinking, what, you're telling us that you've got to stare at a screen all day long to pick up this issue and dig into it? That won't work, and it doesn't. So let me introduce another essential internal tool, which we call Skipper, a nautical theme going on here. Skipper is a key component of our alert and incident management framework. Its primary role is to enrich alerts, making them clear, readable, and meaningful so teams can understand the issue at a glance. When a service impacting issue arises, Skipper ensures that the right people are brought together quickly, enabling efficient resolution. Here's a quick example of an alert forwarded by Skipper. The title of the alert states that a service maintainer of the engaged service is invalid. There's a brief description of the alert. In this case, one of the service maintainers is not listed in Active Directory, likely because they've left the business. This alert helps us identify and clean up outdated references in our source code. This alert also shows the email of the address. I've marked it out a bit so you can't see the exact email, but you get the email of the person that has left. All current engaged service maintainers have been notified about this alert. We would expect them to pick it up and update the code themselves without any ops involvement. At the bottom, you can see a green box with Wayne's name on it. This is the acknowledge box. Wayne is a maintainer for the service and has acknowledged this alert, so in my operational role, I can see that and not worry about having to chase someone to pick up this alert. I know it's been handled so I can move on. Lastly, if this was a serious alert, you could create an incident. I'll show that in a minute. Or you can silence alert. Silence might be used for, say, you're going to decommission this application in a couple of days. You don't really want to fix this issue, so it's going to be killed off anyway. Silence it for a couple of days. Here's another example of alerts, this time showcasing how a Skipper improves our troubleshooting process. Skipper forwarded an alert indicating an unusual spike in 500 errors for the MTD listings service, a deviation from the average over the past 6 hours. The alert also includes useful links such as a runbook. An alert like this requires reviewing logs, service metrics, and tracing. Tasks that are manual and add time to investigation, prolonging the service impact. To enhance efficiency, we upgraded Skipper's capabilities. If you look at the bottom of the alert, you'll see that Skipper has added 5 replies. The first reply shows Skipper advising us that it's found 5 traces with errors. It provides the command for running a more detailed trace and advises it will do one itself in a minute. I won't look at that because we've already shown traces. It also advises it's found 5 application logs with an error and shows a quick sample of the output. This alone might be enough for you to work out quickly, I know what the issue is. Next, we see the output from one of the errors found in Cloudflare logs, so application logs and Cloudflare logs, etc. There's also guidance on bot scores and lists of other internal services noted in the trace. Again, more essential information helping you form what the issue might be. And lastly, I think this is really cool. The next reply, Skipper highlights that deployment was made to that service within the last 30 minutes and suggests it might be worth checking it out. It provides a link to the pipeline and the commit history, and also pings poor Chloe, as she was the last person to commit and trigger this pipeline. Skipper has been pretty busy. At this point, Chloe would typically acknowledge the alert and revert to a last known good release. Although this scenario is rare, when it does happen, the incident is usually resolved within minutes, light years ahead of how it was before, 30+ minutes. But what if Chloe wasn't around? Skipper has alerted all the maintainers for the service, so not relying on one person to take action. As last resort, if this alert is not acknowledged, after a few minutes, my team will probably pick it up and start investigating the issue. It's not finished there, though. So Skipper considers any rise in 500 errors a critical incident requiring immediate action. Due to this, Skipper automatically creates an incident. This will bring together the service owner, maintainers, ops engineers, and delivery platform team. This essentially brings together a crack team of people in one place. I can sort of hear the A-team music as I was typing this going on. This team collaborates with a single goal, resolving the incident as quickly as possible. We don't have SLOs, OLAs in AutoTrader. It's pretty much, there's an issue, drop what you're doing, you fix the issue, that's it. There's no roundabout from that, that's what you have to do. Reaching this level of monitoring and response efficiency took time and refinement. Initially, the team faced alert fatigue due to the volume of alerts, with a lot of frustration when we put this together in the first place. This was due to us still tweaking the thresholds and the service owners and maintainers taking a while to get used to their responsibility. Well, why aren't ops doing that? Why have we got to do that? It's your app, you take responsibility. So it took a while to get into a happy place, which we are now. We also regularly go up to 20 days without any alerts going to our on-call team out of hours, much to the delight of our ops engineers. Now, this is alerts, pick up alerts, automatically creating incidents. But what happens if you spot an issue that hasn't been picked up by monitoring for whatever reason? Well, you want to create an incident manually. You can do this via Slack via this form. Simply, few details, short name, brief description, do you wish to pull in the delivery platform team? It might be your issue is you know what it is, you don't need more support, so you don't pull them in. It might be you don't know what it is, and you do need more support, so you pull the team in. Basically, that's so there's no sort of like, no point pinging people if you don't need to ping people. When you fill out the form, you push the create button and an instant channel is created in Slack. At the top, you can see the name, today's date, and an instant channel prefix, like prefix to AutoTrader, working group, WG, instant channels, INC. Easier to group these in Slack. You can then see some useful commands and a description of the incident. Lastly, a brief message asks you to add a hand wave if you join the channel and you want to assist the investigation. I then add a brief description. Now, no, I've already added one. If this was a real incident, I'd probably add more information describing the impact, maybe some logs or screenshots. So, incident's been raised, and now I need some help to investigate. The quickest way to get help is to reach out to the app maintainers, service maintainers. I could just add the group name, but I have another option. I'm not sure what the command is, so I've done @skipper asking for help. It lists a whole load of commands in what I can use Skipper for. One of those commands I choose is @skipper include app on call bot. This automatically adds the service owners and maintainers into this channel and pings them. We also noticed, though, that it's added a service called Poker. So why has it done that? Well, because it's microservices, it might be that what it is, on-call bot connects to Poker, and they might need to know about the issue as well. So they're dragged into the incident to help investigate as well. Next, you'll see Johnny adds a hand wave and advises he is investigating. I can now breathe a sigh of relief because someone's investigating the issue. Hopefully they're going to fix it quite quickly, which in this case it does. It quickly identifies and pushes out a fix. If this was a real incident, obviously he'd probably add a whole ton more detail about what he spotted, what he's done and stuff like that, and keeping everyone in the loop. So, issues fixed, I close the incident. Now, Skipper's connected to a large language model. So, it generates a condensed timeline and short summary of the incident, which can be fed into post-mortem if needed. Now, this is like really, really useful. When we used to do post-mortem years ago, AutoTrader, you go into a room, an hour post-mortem, the whole hour was spent. What time did you do that then? I did it at 10:05. Sure, I thought it was 5 o'clock. No, I did trying to work out a timeline. So right, achieve a timeline, but not actually going into detail. This gives you a timeline. So at the meeting, you're literally talking about what to do so you're not in that same position again. Lastly, Skipper asks you to delete the channel after post-mortem has been run and gives you info around how to run one. So, final part of talk, key takeaways. First, avoid the temptation to lift and shift to the cloud. Rethink your approach and maximize the cloud benefits. Use migration to fix long-standing issues and fully leverage cloud-native features. This will boost performance and efficiency whilst cutting costs. It's worth saying, cloud platform is cheaper than data centers. A lot of people go their way with cloud platform cost spiral. We've kept ours at a good number of cost efficiency. Secondly, embrace the change that come with migration. Use this transition to enhance your monitoring and observability practices. Encourage self-serve across teams by adopting a platform as a product model. This shift fosters agility, allows your teams to focus more on solving unique product challenges rather than getting bogged down with infrastructure concerns. Lastly, Commit to completing the migration. Very important. It's essential to see it through to the end to avoid the pitfalls of hybrid systems or hybrid clouds, which can complicate your infrastructure. By fully transitioning to the cloud and decommissioning legacy systems, you reduce the burden of maintaining outdated infrastructure. This frees up resources and simplifies your operations, enabling your org to be more efficient and responsive. Remember, our migration took 2.5 years longer than planned. We knew we had to persevere and see it through. I'm so glad we did. Thank you. Hope you enjoyed the rest of the conference.
Do you want to do one question?
As long as it's easy.
Has anyone got a burning question? Perfect.
Hi. So especially when it comes to the security remediations that you had, it sounded as though there was a slightly siloed approach in terms of it was done on a very project-by-project basis. How do you go about challenging that to reduce the amount of replicated effort that you've got across a wider business unit?
Now you mean, or before?
Before, sorry.
Yeah, before security wasn't really done properly, essentially. So the reason why we got more released now is because in the past, when we released an application, it was just for application updates. No security stuff was took on board, and it was really hard for us to do what's right by security. Another big reason moving to public cloud is a lot of that is easier. Now it's down to security is built in a platform. You don't need to worry about service security because it's all built on a platform. If you try to push a service live, if it's got CVEs that are like critical, you can't push it to a platform. You can't bypass, you can't get around it. You have to fix those CVEs. There is a channel discussing CVE. So essentially, in the past, yeah, we were open to, we're quite lucky. I think we didn't get massive issues. Yeah, yes, it was hard. Now though, we build it in. So if we've got security, if you think about security, we're all thinking about enhanced security on the platform, not you worrying about doing it via the app.
So the question was more sort of when you mentioned about the upgrade version of Node, for example, which is very project-related and sort of like service-related. Is that still done at the platform level, or is that then project level, and again, reducing the duplication at that point?
That's all done via the team app owners. Okay. So we wouldn't do that, it's down to you, but it's very simple to do that. Literally, it's testing, updating code, and it's done.
Awesome, cheers.
We'll do one more. Someone at the front.
Well, firstly, thank you. That was great. Thank you very much. The question is, knowing what you know now, what would you do differently if you had to do it again? What advice would you give us?
That's a good question. And I think it's, honestly, it's been a journey. I think if we hadn't done what we've done, we'd probably been harder to get us where we're going to because we pick up lessons all along the way. I had a discussion with someone else this morning. It isn't a case of that, I commonly get a question, how do we do what you've done and get there tomorrow? Well, live 4.5 years of us going through this pain. You experience it, you learn it. As a culture, as a company, we've grown so much as a culture. I've been in 20 years. There's regular people there, been there so many years, same amount of time as me. You grow together, you sort of know, you're always going towards one path. So there's many factors to it, but I wouldn't change one thing. It's been a good journey, but we got to where we got to. Does that make sense?
Yes, thank you.
Yeah. Thank you.